all the equations that we come across throughout the rest of the course are going to involve this step, okay? So think about something like this. When you were in Algebra 1, your first equations were things like this. Okay, and that might be even simplifying things a little bit more than what they were in Algebra 1, but that's an equation, yes? Pretty trivial though, correct? We know what the answer to that equation. We don't have to do any solving. So maybe a step from that would have been, maybe you did like x plus 1 equals 4. Okay? That would have been a step previous to x equals 3, right? Okay? You would go through one procedure to solve for x. Subtract 1 for both sides, right? Okay? You also saw then, so you did those, you did a lot of those, and then you did a lot of these, like 2x equals 8. And you solved a lot of those for just x, right? Just one step, okay? But then we found out that as the equations became more and more difficult at their onset, did you always get in the last step something like x plus 1 equals 4 or 2x equals 8, and you had to conduct yourself like you did when you first learned how to do those, right? That's what we're going to do today. I'm going to teach you ultimately the last step of every trigonometric equation, and then we'll build the trigonometric equations to look more and more difficult, but they're always, no matter how difficult they always come down to something like this at the last step. Does that make sense? Okay. If we don't know how to do this last step, it doesn't matter how proficient we are with getting to that last step. We can do 10 minutes of work to get to this last step and not miss a single step and be 100% correct until this last thing, but then totally bomb this and not have a clue to what our answer should be. Does that make sense? Okay, so this is something we need to make sure we understand. Couple things that play here. They're going to tell you where your answer has to reside. Okay, here it's between 0 and 180. Another common interval is 0 to 360. Okay, you just got to pay attention to that. Those, like I said, those are the most common, but they could be anything. They could be 0 to 90. They could be 90 to 180, whatever. Okay, but that's the interval that we're going to focus on. Here's the sine theta equals 0.4. Now I'm going to rewrite this just to give myself a little bit more room on the right-hand side. Okay. Right now that theta is stuck inside that argument, much like if I had radical x equals 2. How do I get that x out of the radicand there? I square. What's the square in comparison to the square root? It's its inverse. Okay? If I inverse this side and use the inverse on this side, I get that x to come out, right? What do you think I have to do over here? Find the inverse. Okay? And so it's the same exact algebra, right? There's nothing different than what we've learned in Algebra 1 and Algebra 2 here. It's just using different inverses, okay, different functions. So now it's sine inverse of the left-hand side and sine inverse of the right-hand side. Okay? Now, the approach that we're taking here is predicated on the fact that we believe and we understand that the sine inverse function is defined per what we talked about last time we were in class. The sine inverse is defined between -1 and 1 and has a range between -90 and +90. Okay? So what that means to us is that if this is going to work the way we want it to work, our theta that's going to fall out of the sine inverse of sine of theta notation on the left-hand side, that is going to be between -90 and +90. Does that make sense? Okay. Now, on the right-hand side, generally, if this is like 0.5 or radical 3/2 or something like that, we would be able to use our special right triangle to figure that out. Okay. But we don't know 0.4, the sine inverse, the ratio of the opposite side and the hypotenuse that gives us 0.4, what angle that is. Okay. So when this is a non-convenient number, okay, we have to turn to our calculators. So I'm going to use Desmos. And I'm just type in Well, let me before I type in the right hand side, let's demonstrate the left hand side first. We had arc sine of theta. Let me just show you that if I go between negative 90 and positive 90, that there's a cancellation of these two things, and the thing that drops out is that theta, or t in this case. Does that make sense? So they're saying if t is 1, if you put 1 degree in there, you get 1 degree back. If I plug in, oh, I'm in wrong mode. If I plug in negative 42 degrees, I get negative 42 degrees back, right? Plug in negative 73, get negative 73 back. Plug in 46, get 46 back. Plug in 70, get 70 back, right? Do you see how there's a cancellation between those two things right there, arc sine and sine, and they give you just the argument back? Is that all right? That's what we wanted right here to happen, just to give us that theta back. If I'm looking at an angle that is not between negative 90 and 90, let's say I'm looking at negative, let's just go from 0 to 180. Okay, so 0 to 180, so 0 to 90 is still in that negative 90 and 90 interval. So I'm still getting that return of whatever my input was, right? If I go above 90, do I get that return? Is there a direct cancellation now? No. Okay, and it's because the sine inverse is not defined for things between 90 degrees and 270 degrees. Does that make sense? Okay, now you did say that they're what to one another? They're supplements. That's a key fact that we're going to need to use here in a moment. But there is not, what I want to see here is that there's not a direct cancellation. Okay. And again, like you've heard me say this before, chapter 6 is almost an identical repeat of chapter 5, except for we use a unit circle perspective instead of a triangle perspective. However, the unit circle perspective is built using triangles. We'll come back to this again. You'll hear me talk about this cancellation concept again in that chapter. All right, so then using my calculator, if I want to find what the sine inverse of 0.4 is, it's 23.578 degrees. Is that okay with everybody? Now I'm using arc sine. You guys remember talking about that? Arc sine is a synonym for the sine raised to, or I don't want to say raised to, but with a superscript of -1, which is notation for the sine inverse as well. If I let that, I'm just going to call that A, just to prove a point. If I go back to cosine, or sorry, the original problem was sine of theta equals 0.4, right? If I type in sine of A now, do we still get that 0.4 back? Does that make sense? So did we solve, we got the right value for A here, correct? We solved this correctly. Does that make sense, everybody? Now let's think about this. Because that, if you go through that procedure, okay, it's 23.58 degrees. We go through that procedure, and that's the only answer I write down, we are wrong. Okay? We are wrong because we're not thinking about what the interval here for our solutions were and what we know about the sine function. The sine function is opposite over adjacent, right? So right now, if I go 23.58, what we're seeing, if that's 23.58 degrees, what we're seeing is that whatever this number here is, divided by that number right there, that's opposite over hypotenuse, right? Whatever that is, it yields 0.4. Does that make sense, everybody? Okay. What kind of number was this opposite side? Is it positive? Is my hypotenuse always positive? Okay. If I were to take this terminating ray, if I were to take that terminating ray and keep revolving it to over here, can you visualize that there is going to be a position over here when I stop that distance right there is going to be the same as that distance right there? So that number and that number will be identical. Are they both positive? Now, because I used that terminating ray to rotate, that terminating ray was this hypotenuse over here, right? So it's the hypotenuse over here, correct? Would you guys agree that that blue number there or that blue number there, whatever they are, when they divide, they should also yield 0.4? Okay. Our calculator does not give that angle, though. Okay? But that angle is from standard position. So if that's my initial ray, that's my terminating ray, the other angle that I'm looking at would be that one there. Is that okay with everybody? How do I find that angle? 180 minus 23.58. Okay? Because we can take that 23.58 and it's also that angle right there, right? Using reflections. Okay? And if that blue ray, or sorry, that blue angle would go all the way down to the x-axis here, that'd be 180 degrees. But I want to stop 23.58 degrees short of that. So theta is also equal to 180 minus 23.58. So that turns out to be, okay, so if I go, I'm just going to say B is equal to 180 minus 23.578, whatever. So 156-ish, right? So now I should be able to say that the sine of A gave me 0.4, and the sine of B also gives me 0.4. When I say type sine of A, it's using the 23 number, right? When I say sine of B, it's using that 156 number. Those are our two answers between 0 and 180. Does that make sense to everybody? Okay. Now, using that same approach, there's a couple of reasons we don't do this any further, and those are our final results. But let's say one reason that we don't go any further is because our original problem said we were confined between 0 and 180, right? We just did that. We don't need to go any further. But let's say that said 0 to 360. Would I need to go and say, because this would have been 23.58 as well, would you guys agree that this angle here would be 23.58? I could do that reflection in the third quadrant, right? So this angle here would also be another theta. It'd be 23.58 plus 180. But here's my question. What kind of number is this right here? That's negative. That distance is negative, right? This is positive. What's a negative divided by positive? Negative. Okay? So can the sine in the third quadrant ever be positive? No. So my argument here is, do I need, if they ask me to go between 0 and 360, can I ever do this? That angle I'd be interested in that I drew would be 203 degrees. But if we evaluate sine at 203 degrees, what's it give me? Negative 0.4, not positive 0.4, right? So because it's negative, we don't want that one because we're trying to solve the equation of positive 0.4. That kind of make sense? So in this situation, two answers. Calculator is only going to give this initial one between negative 90 and positive 90. Is that all right? Okay. Let's do the cosine one. Cosine of theta equals 0.4. Okay, cosine of theta equals 0.4. You're going to see some relationships here between the sine and the cosine. They are complement to one another. So we should get like an angle like 66 degrees here, because the last one was like 66.4 or something like that, because the last one was 23.5. But the way that I solve this is same approach. I want to get that theta out. So I go cosine inverse of the left-hand side, cosine inverse of the right-hand side. There's a cancellation. But that cancellation only happens when theta is between 0 and 180 now. So arc, cosine, t. So I want t to be between 0 and 180 instead of negative 90 and 90. Now you see there's direct cancellation all the way through from 0 to 180, right? Okay. Now if I were to go from, let's say, 90 to 270, Okay, so this 90 is an overlap from the 0 to 180, so you're going to still see a cancellation there. But when I get above that, is there cancellation directly there? No. Okay, but there is a relationship here that is going to be useful eventually. Does that make sense? Okay, so we're looking between 0 and 180 here. So what we're saying then, if I take my cosine inverse of 0.4, so arc cosine of 0.4, we get 66.42 degrees. Okay? So I'll draw that angle here, 66.4 degrees. That means this number, whatever that number is, divided by whatever that number is, because that's the cosine, right? Adjacent divided by hypotenuse. Whatever those two numbers are, when I have a 66.4 degree angle, they divide to give me 0.4. Is that doable? Now, can I do the same thing over here? Why not? Okay, so this 66.4 degree angle does exist over here. I can reflect anything I want to. The question then is that theta right there unanswered? Is 180 minus 66.4 an answer for this? Well, Jim is saying no, because that side right there, that number is going to be negative, right? That number right there is going to be positive. So the cosine of whatever that theta would be negative 0.4 and not positive 0.4, like what was asking the question. Okay, you can justify that or recognize that with taking, let's just call this A. So we'll go B is equal to 180 minus A. So the question is, well, can I take the arc cosine, or sorry, the cosine of B and still get 0.4, and I don't. I get negative 0.4, right? Okay, and that's the whole process we learned in Algebra 1. Once you find an answer, plug it back in and see if it makes your argument true, right? Makes your equation true. Here it does not. Okay. What if I did this, though? Does 293.57 make cosine of that angle 0.4? Okay. Is that one of my answers, though? It is not one of my answers, because what do they ask me to be between for answers? 0 and 180. Okay. However, let's say they change it. Let's say that they want an answer. Let's say theta is between 0 and 360. That's the other common interval they'll ask us for our answers. Then we could do that. We could take and say that this angle right here has got to be 66.4, right? So then the theta that we would be interested in would be that theta there. So we would take theta equal 360 minus 66.4, and that would be a second answer. Is that okay with everybody? Okay. So now here's my question. So now this is for the interval between Control C, V. All right, so let's say that we're looking between 0 and 360 for answers. These would be two answers for that, right? What if I said let's look at 0 to 720? What do you think I would do with these two answers to get all my answers between 0 and 720 at 360? So if I say, I'll just go to cosine of A plus 360, does that still give me 0.4? Well, if I go cosine of A plus 360K, let's add a slider for K. Does it matter? Let's make my steps 1 for K. Doesn't matter what K is. So it's, if K is 0, I'm asking cosine of 66 degrees, right? If it's 1, I'm asking 66 plus 360. If it's 2, I'm asking 66 plus 360 plus 360, right? They're all coterminal, right? So there's an infinite number of solutions if we don't provide a condition for what we want our solutions to be on, okay? If they don't provide a condition, so they might just say, find all angles theta satisfying the given equation, and they don't give you that argument, that condition of a solution interval, then you assume that there's an infinite number of solutions. And basically what you would do is you would find the two between 0 and 360. So you would find this one right here. Okay, so you would say, in your final answer, you would say theta is 66.42 plus 360 times k, where k is an element of your integers. And then you would also say theta is 293.578 plus 360k, where k is an element of your integers. And that produces then all those replicated coterminal angles to positive and negative infinity. Does that kind of make sense? Okay. Now, what stinks, if that does not make sense, okay, we need to make sure that we address that, because, like I said, when we get into, let's see here. My mouse stopped. There we go. When we get into, let's say, chapter, I don't have my other chapters up here. When we get to chapter 7, every equation that we come across, we will dwindle it down to that or to that, and we'll have to do this whole process here inside those questions. Your calculator won't always give you everything you need. Does that make sense? So we can't rely fully on that. Time we get out of here? 55, 1 minute. All right. We'll start with example 7. Last class got through example 7. We'll do example 7 and example 8 tomorrow. And if need be, we'll come back up here and do these examples as well. My hope is to get through, there's 2 remaining sections, law of sines and law of cosines. Those are things that we've seen before. Should have seen them in Algebra 2. Should have seen them in geometry. I know we saw them in geometry. Algebra 2 might have been different because of the pandemic, but we will go through law of sines and law of cosines relatively quickly. Those of you that are in physics, maybe you've used law of cosines recently. You guys talk about vectors or anything yet in physics? Okay, so you should have used law of cosines with finding the angle between 2 vectors. But we'll target that, and then hopefully test middle to late, like I'm thinking Wednesday, Thursday of next week. Okay. And then we'll jump into chapter 6 and keep on moving.